look at some examples of substitution method. And this first example, remember the first step to solve these is to solve for one of the four variables. Again, I said it doesn't matter which one, either variable, either equation. As a suggestion, if you were to solve for this first x, you would have to divide by a 2 at some point later in the process, and that will create some fractions. Same thing for this y. If I solve for this y, I have to divide out the 3, and that will also create fractions. So if we can avoid the fractions, I would recommend that. And so instead of solving for one of those, I'm going to solve for a variable that has a coefficient of 1 whenever possible. And here both the y in the first equation, the x in the second equation, have a coefficient of 1. I'm going to choose the y here in the first equation, and so I'm going to rewrite that first equation. To get y by itself, I need to subtract the 2x in order to zero it out. I better do that from both sides. So that 2x term is gone. Y is going to then equal 7 minus 2x. Now remember, 7 and 2x are unlike terms, so I cannot combine them. They have to stay separate. Now the second step in solving these systems is to substitute the resulting expression into the other equation. And so that's what we're going to do here. We're going to take the second equation, which is x plus 3y, and the y is going to become this new expression. So I'm going to put a set of parentheses around it so you can see what's going on. It's equal to negative 4. Okay, so now if you follow this along, it's x plus 3y, this whole blank spot is y, equals negative 4. And then we take this expression for the other y and plug it in. So y becomes the y in the other equation, 7 minus 2x. Okay. Then we can distribute and solve. You guys remember how to distribute. Distribute the 3 into the parentheses. You get x plus 21 minus 6x equals negative 4. Combine my like terms. 1x minus 6x is minus 5x, or negative 5. Add 21. And then we're going to subtract the 21 from both sides. Negative 4 minus 21, both are negative. So we add the values, get 25, and then use the sign from the bigger number. We then divide out the negative 5 to free up the x. And that's going to give us an answer of 5 for x. Okay. Remember, we're not quite done yet. X is 5, but we need the y value to get the ordered pair. So I take that 5 and I have to plug it back in. Now it doesn't matter which equation I plug it into. Either one will work. So I'm going to plug it into the top equation. Again, it doesn't really matter. 2 times that x value plus y is going to equal 7. Again, this x value of 5 is what's going to go in place there. And then we just solve for y. So this is a 10 plus y equals 7. Subtract the 10 from both sides. Opposite sign, so I subtract their values, use the sign from the bigger number. Y equals negative 3. And so my final answer, remember, needs to be an ordered pair. You must put it in ordered pair form. And you're going to use 5 and negative 3 as the ordered pair. Okay? Good. The next video we'll do another example.